So in today's session, we will discuss again VPC resources like NAT gateway, NAT instance. So to provide the internet to private subnets, we'll use NAT gateway and NAT instance. Then NACL, NACL or network access control list, which provides the firewall rules at the subnet level. Then, like we will enable VPC peering and will confirm whether that VPC peering is connecting or not. So these all the labs will do. So first we are in the Seoul region here, and I'll create a VPC. Then that VPC will like make it into subnets. Set 10.12 I'm using here. 10.12.0.0/16 for the VPC we have given. Then for the subnets, I'm giving here 10.12.0.0/20 is the CIDR block we have used. In the previous session, we have used /24. With that, we got 256 IPs. But here I have given /20. Can you tell me with the /20 how many IPs we are going to get it? So total how many number of IPs we are going to get it with the /20?
Class 16 second,
No, no, /20. Slash six,
4096,
yeah, /16 will give 65,536 IPs.
65,300,
Yeah, so now here we are,
530.
yeah, so here we are getting 4096 IPs. Hyphen 5 have been used by AWS internally. Then we are getting 4091 IPs. So then can you tell me the next CIDR block here? What is the next CIDR block here? So 10.12 dot. So normally we used to give 1.0, right? But if it is only 256, it is to take 1 dot. But here we have 4096 IPs. That will take, say, if each row or each series we have 256 IPs, then 4096 IPs will take almost 16 rows kind of thing. That means 0.1, 1.1.0, 2.0, 3.0. Like this, it will end at 15. It will end at 15. Then here we have 10.12.16.0 we are taking. So yesterday we got only 0, 1, 2, 3 because we use only 256 IPs. But here we need to assign 4096 IPs. That each row will have 256 IPs means total like 16 rows it is taking. But why we have given 16 is it started with 0, 15 is going to be ended. Next series starts from 16. So this is in this series, what is the last IP is 10.12.31.255 is the last IP. In this series, what is the last IP? Can you tell me? In the above series, what is the last IP is 10.12.10.12.15.255 is the last IP. The next series starts from 16.0. 16.0. This last IP is 10.12.31.255. Okay, then can you tell me one next series? What is the next series here? 10.12.32.0/20. So this is the next series we have. So this is the next series we have. Then 10.12.48.0/20. So like this we need to attach if you are using /20 we are using not 1, 2, 3 like this we can't give because that will get overlapping. Any doubts on this? What is the challenge we have by giving /24 to the subnet is only 251 is the maximum number of IPs we are getting. Okay, so only the maximum number of IPs are 251 we are getting. So now here we need to give more number of IPs. That is the reason we went for slash 20. So we went for the slash 20 here. So these resources I will create. So I'm going to create a VPC here. So only VPC I'm creating. Okay, so now we need to give like one VPC name. So I'll give Nokia Online is my project. So Nokia Online Seoul VPC. Okay, so Seoul VPC. So then I have given here 10.12.0.0/16. As of now, we are not choosing IPv6. If we want even IPv6 also, we can select. But in the private network, we are using IPv4 itself. Even in the public subnet also, AWS is providing IPv4 address itself. Optionally, if we want, we can choose IPv6 CIDR block also. Now VPC has been created. I'm going to create the subnets. Creating a subnet. I'll choose Nokia Online VPC. Then here, Nokia Online subnet 2A. Public I have taken. Then zone also I'm taking 2A. Then here 10.12./20 I have given. Say here if you see 4096 IPs we got. What is the problem if I assign /16 itself here? Okay, if I assign the complete IPs to one subnet itself, what is the challenge is we can't create other subnets because all IPs have been exhausted. Okay, so hence I'm creating subset of that itself. So that is the reason I'm using 20. That means here we have 65,536 IPs, but to this we have assigned only 4,096 IPs only we have assigned. In that also 5 would be used by AWS 4091. But that doesn't mean tomorrow itself we are going to keep 4091 IPs. We are going to design this one for the next 2 to 3 years, and we may sometimes auto scale also some servers automatically. At that moment also we should able to get appropriate IP addresses. So for that purpose, for the long term planning, we are keeping /20 as our CIDR block. Then I'm going to create one more subnet. I'll give here 2A private. So I'm going to keep 2A itself as my zone. So can you tell me the CIDR block is 10.12 should be fixed because we given /16, right? That first 16 bits are fixed. Next 16 bits only are changing. Okay, so yeah, please tell me what is the next range. What is the next range here? 16.0/20. Create the subnet. So two subnets I have created in the 2A. One is public, one is private. I'm going to create one more subnet. So this I'll make it to be public. And definitely we need to choose the zone is to be, otherwise There is no guarantee we'll get the same 2B. Then 10.12 dot 32.0 slash 20. I'm going to assign to this, and I'll create one more subnet. I'll create one more 2B, that should be 2B private. 2B private. Sorry. Say here we can choose 10.12.48.0 slash 16. Then I'm going to create the subnets. Almost 4 subnets we want. So now we want to make it 2 subnets in that 4 subnets public. For that, what we need to do? What we need to do for that? So we need to integrate with the internet gateway. So I'll create an internet gateway. So Nokia Online Seoul internet gateway I have created. Then I have created the internet gateway here, and that internet gateway need to be attached to VPC. To our VPC, we need to attach. Once we attach to this, we need to create a route table. By default, we got one main route table, but I'm going to create a route table. That route table, I'll call that as Seoul Nokia Online Seoul internet route or public route. We can keep it. And I'm going to choose our own VPC. We are creating a route table. By default, we'll get one route, that is VPC cider block. VPC cider block uses the local router. It's local router, but I'm going to add one more route. I'm going to add one more route. So that is 0.0.0 uses internet gateway. So that internet gateway we are going to select. Once you attach that internet gateway, now this need to be attached to the subnets. Edit subnet association. Then we need to choose those 2 public subnets. Say 2A public, 2B public. I don't want to make it these 2 private subnets as public. So already we have done all this. So I'm going to save this and go and check from the subnet wise confirm. So these private subnets have been not attached to those internet gateway route table. So go to check here route table, and here we got 10.12.0.0 slash 16 itself we have. Okay, so once we added these route tables, all this, so now in the subnet level, for the public subnet, we need to set up one more setting, auto assign public IP address. Then here go to actions, edit subnet settings, enable auto assign, and save that resource. Okay, to the another public subnet also, I'll enable the same setting. Okay, so now we can like with the internet gateway, we can publicly access. We'll get the internet also. And if we want the private subnet, want internet, then what is the solution? Please tell me. Say if we want to give the internet to the private subnets, what we need to do? For the private subnets, we need to attach. We need to attach the internet. Sorry, NAT gateway need to be attached. NAT gateway need to be attached for that. So I'll create a NAT gateway. Can you tell me in which subnet we should have the NAT gateway? In which subnet we need to use NAT gateway? So public subnet or private subnet? Yeah, say in the public subnet we need to keep the NAT gateway. Say here we'll go for NAT gateways. I'm going to create a NAT gateway here. Okay, so now Nokia Online, Seoul, NAT gateway. Subnet here definitely either 2B or 2A, anything public subnet itself, we need to choose. So I have chosen 2A public, connectivity type is public, and definitely we need one elastic IP. So we need one elastic IP. Okay, so then I'm going to create an NAT gateway. And how we can attach this to the private subnet is, again, we need to create a route table for that. So we need to create a route table. Say now, Seoul or Nokia Online Seoul NAT gateway. Then I have created that route table. Edit routes, add routes, NAT gateway. Don't choose here internet gateway. Then that will become public also. So now here I'll tell one statement. Tell me whether that is correct or not. Okay. So now if we attach internet gateway, it will become public subnet. If we attach NAT gateway, it will become private subnet. Yeah, can you correct me whether which is correct one? Among those two statements, one statement is wrong. What is that?
Second one. One.
Second one is wrong. What is that? Can you correct that statement? So what wrong in that?
If you attach NAT gateway, it will become private sub.
Yeah, what is the correct statement? By
public subnet.
default, in custom VPC, subnets are private only. We no need to do explicitly anything. If we want internet to those private subnet resources, then we need to attach NAT gateway or NAT instance to that subnet. Means always don't keep that one. Okay, say we have a patching activity this weekend, or we want to access some APIs, or we want to download some softwares. At that case only attach the, at that moment only attach the subnets. Don't attach permanently to that. Okay, so now we have attached that NAT route table. Assume today at 9 o'clock, morning 9 o'clock, we have a patching activity. Then I'll go to that subnet. Okay, so maybe to the 2A private. So we don't have patching activity in 2A private. Then don't attach to 2A private. Only for 2B private, we have the patching activity. Then for the 2B private, I'm going to attach my route table. Okay, say as of now, that is having a main route table itself because it's having only one rule. I'm going to edit the route table association. This I'm doing from the subnet to route table association. Okay, so then that route table is not internet route, NAT gateway route I'm attaching. Okay, so now I'll go and check that subnet whether which route table it is having. It is having two routes. And once, say, suppose at 10 o'clock, our patching activity is done, again bring back main route table itself. Okay, always like keep the main route table without editing any routes. Then only that should be private. Okay, that means if the route table is by default it is getting one rule, that is our VPC cider block. In our scenario 10.12.0.0/16, it uses local. So this rule, like by default, will get for any route table, but main route table keep only this rule. In the main route table itself, if I attach 0.0.0.0/16, sorry, 0, and if I attach here internet gateway, what is going to happen is all my subnets are becoming public itself, because main route table would be by default attached to all. And if you create a new subnet also, by default that itself is going to attach to that. So that is the reason don't modify. That is the reason don't modify existing like main route table rules. Don't add. Keep it default itself. Keep it default. Okay. So once we added this, now we have created an NAT gateway also that has been attached, and yesterday we tested that also. Now in the NAT devices, the purpose of NAT devices is same. Okay, so to provide internet to private subnet missions. So to provide the internet to the private subnet missions, we are going to use the NAT devices. Okay, so now like we have two types of NAT devices. One is NAT gateway. NAT gateway is managed by AWS. In the EC2 instance, our own customizations are possible. For the NAT instance, okay, so NAT instance, we can create our own NAT instance, and that NAT instance also need to reside in a public subnet instead of NAT gateway. Both the use cases you no need to do either NAT gateway or NAT instance in your environment. You tell we have NAT gateway. Okay, high availability, scalability, high availability, scalability, maintenance, everything is taken care by AWS. For NAT instance, we need to take care. Okay, and Elastic IP is mandatory for Elastic IP is mandatory for NAT gateway. For NAT instance, normal IP also we can keep. But technically, both NAT gateway, NAT instance need to reside in the public subnet itself. Then only those will get the internet. So, who will provide? Can you tell me one small scenario? Who will provide? Who will provide internet to NAT devices? So can you tell me who will provide the internet, because it is sharing that internet to other devices, to the private subnet missions. It is sharing just like maybe assume a hotspot kind of thing. But who is giving that internet to those devices? Who is giving those internet to those devices?
Internet gateway.
Gateway.
Internet gateway is providing. That is the reason those should be kept in. Those devices should be kept in the public subnet. We need to keep it in the public subnet. We need to keep. Okay. So then I'll create one NAT instance. I'll create not from the VPC. NAT instance we can create from EC2. We can create from the EC2. So go to EC2. So now from the instance, we need to create an instance. So it's launch an instance. So here I'll give Nokia Online, Seoul, NAT instance I'm giving. Okay, so all these days we created the instances, right? But we shouldn't use these AMIs. These AMIs are not instance compatible. Browse for more AMIs. That means AWS is providing some special AMIs for the NAT instance. That instance, that AMI only we need to use. Okay, say here search for NAT. Search for the NAT. Okay, so then here we don't have in quick start AMIs, we don't have my AMIs also, we don't have. Go to community AMIs. Say with the NAT, we need to filter the community AMIs and we need to choose the appropriate NAT one, not NATs. NAT we need to choose. So NAT hyphen VPC is something would be there. That AMI itself we need to choose here. Yeah. So now here we have, right? Uh, Amazon AMI VPC hyphen NAT. Okay. EBS attached one. Otherwise here also this one. Okay. It's Amazon Linux, but these are the old AMIs, no issues. So I'm going to select this. So that these AMIs are not compatible for NAT instance. The appropriate NAT AMI itself we need to choose. And definitely, like it should be kept in our VPC. And if you want, you can create a new key pair or existing key pair also is fine. I given here NAT key pair. Then in the network settings, if you go with the default options, there is no use. So definitely we need to choose our own. Yeah. And mandatory, this should be kept in. This should be kept in the private subnet or public subnet. This should be kept in the public subnet or private subnet. It should be in the public subnet itself, either 2A public or 2B public also fine. And mandatory should have a public IP also. Then remaining all default options I'm going to provide. So now here we have a slight difference between NAT gateway and NAT instance. Okay, so NAT gateway billing is based on usage. Means I have 100 servers in my private subnet. They have used lot of data to download the internet files and or maybe software files, all those. Then the billing is more. But with the NAT instance, for the instance, we need to pay the money. Okay, for that EC2 instance, what are the charges we have? For that, we need to pay the money. The NAT gateway billing is based on the internet usage. Okay, and one more thing with the NAT gateway is NAT gateway it can scale up automatically also. That means if more demand comes, automatically it can scale up also. NAT instance scalability depends upon the type of the instance we have chosen, that IOPS, all those also, the type of instance we have chosen, only that is only is going to use. Okay, so which one recommended is NAT gateway is recommended to use. But NAT gateway one challenge is our own security groups or our own security group rules we can't define. Whereas if you go for our own security groups, if you want to define, then we need to use the NAT instance. Because in the NAT gateway, we can't enforce our own security group rules. Okay, so once we done this, we created a NAT instance here. So is it disconnected?
Yeah, connected again, Srikanth. Just now disconnect.
Okay, okay. So then here instead of 1 second, I'll share. Say here we are going to attach this NAT gateway we need to attach. Already we have NAT gateway has been attached to this, but in this use case, I'm going to attach the instead of NAT gateway, I'm going to use we attach NAT gateway, right? Instead of NAT gateway, choose the instance, and that NAT instance we need to select here. That NAT instance ID or network interface we need to select. No need to use both. Okay, for one VPC, either NAT gateway or NAT instance. Okay, so then, like even yesterday we tested, right, whether internet is coming to that private subnet or not. Try to check that behavior also. And one more important setting is need to be configured in the NAT instance. That setting is So what is that setting is? Say this is our instance, right? So go to that instance actions, networking. Say here we have one option. What is this? What is this one?
Change source and destination.
Change source destination check. So by default, source and destination check we shouldn't stop for the security purpose, but only for NAT instance this should be stopped because the source who is taking the internet is NAT gateway, but it is giving to the destination is other instances which are in private subnet. If I don't stop this one, okay, AWS will block the traffic. Okay, even if you want to give the hotspot also, you need to enable the hotspot or not. Okay, so then we need to go for, so this should be stopped or enabled. Source and destination check. For other instances, it is very risky to stop it, but only for the NAT instances, we need to stop this. If I don't stop this, we are not going to get the internet to private subnet missions. Okay, so please tell me what is that setting? In the instance actions, networking, source and destination check need to be stopped. But normal for other instances, it's not at all recommended
To stop.
to stop that. Only for the NAT instances only, this setting should be stopped. Otherwise, even if you create also, there is no use because AWS will block the traffic because it is going from the NAT instance to another mission. It will block the traffic. Okay, so NAT instance is nothing but it's just like a mobile hotspot kind of thing because your mobile internet you are sharing to other devices. Okay,
Okay, sir.
so then in the VPC there is one more concept called as NACL. So by default for every VPC, one default NACL, one security group will get. Both are, what is the similarity between both of them is, both are firewall rules. But the firewall rules, NACL have been attached at subnet level. Security group firewall rules have been attached to those have been attached to security group resources have been attached to inside the subnet. Maybe we have a EC2 instance, otherwise maybe RDS, load balancers. For those resources, we are attaching the security group rules. Okay, at the subnet level, so first outside we'll have a NACL. Inside the resource level, we have security group. If I block a traffic at NACL level and if I allow at the instance, then what is going to happen? Have blocked the traffic at NACL level, but allowed the traffic at the security group level. Then what is going to happen? Okay, if I block it at the NACL, then that is not going to communicate. Okay, if I block it at the NACL, even if I open at the security group also, the NACL will block the traffic. NACL will block that traffic. Okay, so now if I go to the NACLs, by default we got one NACL definitely for each and every VPC. We'll get one NACL, and this NACL has been attached to all the 4 subnets we have created, right? Okay, so then we'll go and check this NACL rules. So try to understand that. So definitely NAT gateway versus NAT instance, internet gateway versus NAT gateway, public versus private subnets, NACL versus security groups. So these are all the mandatory questions from the VPC. Then here try to understand. So NACL also have the inbound and outbound rules. Already we have seen this in the security group, but these all are the subnet level we are going to attach. By default, we are getting one NACL, and that has been attached to all the subnets in the VPC. In the real time, we can choose, even in the real time, what we can choose. For the public subnets, one NACL rules. For the private subnets, our own NACL rules also we can define in the real time. But by default, all subnets, we are getting the default NACL itself. By default, we are getting the default NACL itself. Okay, so then here in this NACL, in the inbound rule, so we have the rule numbers. In the security group, we don't have the rule numbers. I will explain this rule priority. So now here it is allow is there, Denny is there. Then we are getting a conflict, right? So suppose assume your parents, someone is allowing to go to maybe a trip, your father is not allowing. Say your mother is allowing, your father is not allowing, or vice versa. Then like who will have the priority? That condition we will follow. So now here allow is there, Denny is there. Okay. So then based on the rule number, okay, so based on the rule number priority, that rule will work. In this 100 is the high priority than this star. Okay. So by default, can you guess whether this inbound rule will allow all traffic? That means by default with the default NACL, we are not restricting any traffic at the subnet level. We are not restricting. Where we are restricting? Where we are restricting the traffic. At the security group level, we are restricting. But sometimes even it's recommended to restrict the traffic at the NACL also. Okay, so then anyhow outbound rules, all traffic is allowed. So inbound also is all traffic is allowed. Outbound also is all traffic is allowed. But for the public subnet, this is fine. But I'm going to create one more NACL. This I want to attach only to my private subnets. Try to understand. I'll create my own NACL. I'll create, say, Nokia Online NACL. This for the private subnets, especially I want to design. I don't want to allow everyone to come inside. Okay. So then my VPC I have taken here. I'm going to create an NACL and I'm going to configure the inbound rules here. By default, in the custom NACL, okay, so in the custom NACL, sorry, this is not that. Yeah, this is the NACL we have created, and this is the custom inbound rules we are getting. In the custom NACL, by default, all traffic is Denny. In the default NACL, all traffic is allowed. But this is the custom rule we have created. In this, all traffic is Denny by default. But I want to allow some traffic. I'm adding a new rule. For that, I kept 100 is the priority I'm keeping. Okay, and I'm giving all traffic. Okay, then the source is 0.0. I don't want to give. What is I want to give is 10.12.0.0 slash 16 I'm giving. So what is this meaning? For the private subnets, only 10.12.subnet only I'm allowing. If I give here 0.0.0, then what is going to happen? From all over the world, the traffic is allowed. But for my private subnet, I don't want to allow that all over the world because it's a private subnet. Only internal Within the VPC, I want to allow. That is 10.12. Only within the subnet itself, if you want to access, then you give the subnet cider, but that is not recommended. Okay? So this NACL we need to attach to which subnets? If I attach this NACL to the public subnet, then there is no use because outside traffic is not allowed. So depend upon your requirement. You don't want to allow the traffic to the subnet level, then we need to create the custom NACLs. The default NACL, like inbound and outbound, it will send all the traffic. So now here, technically, NACL versus security group will discuss. NACL is at firewall rules at subnet. Security group is firewall rules at instance level, or inside we may have RDS, or we may have a load balancers also. Okay, so then allow and any kind of rules we have at, can you tell me, allow and any kind of rules we have either at NACL level or security group level? At the NACL we have. In the security group, there is no like any kind of rule. Which one you want, you just allowing it. Remaining all are by default Denny itself. Say if you don't open anything, nothing will come. If you want 22, 22 we need to open. Okay, but if you want to Denny 22 only, it's not possible at NACL. By default, that is Denny itself. Okay, say allow and any kind of rules we have at the NACL we have. And one more important is rule priority also. Rule priorities like 100 and 200. 100 is telling Denny, 200 is telling allow. Then which one will work? Allow or Denny? Which is having the higher priority? 100 will have the higher priority than 200. If you have 200 and 300, 200 will have the higher priority than 300. Rule priorities we have at NACL. So we don't have at security group. Okay, so today again, once again, go and create a security group also. Okay, so now here we have allow and any kind of rules we have at NACL. And if you allow and any, if I am getting a conflict between the rules, then we can give the rule priority also. Every rule will have a priority number, and based on that number, we are going to get the resultant set which rules need to be applied. Okay, so can you tell me these three differences? So what are the three differences? NACL is at subnet level firewall rules. Security group is at the instance level. Okay. Then final we have one more important difference is there. Okay, very important at the firewall level because NACL all these are firewalls itself, but not physical firewalls. These are virtual firewalls. But there is one more important rule is there. That rule is NACL is stateless, whereas security group is stateful. What is this difference? I will explain. Uh, if I add an inbound rule, automatically that rule is added in outbound also. Okay. If it is stateless, say from the firewall wise, what is that meaning of stateless? If I add an inbound rule, automatically that rule is added to outbound also. If I add an outbound rule, automatically that rule. Say suppose even in the security group, it's stateful because uh, almost outbound traffic is all traffic is allowed. Okay. If it is stateless, what is going to happen? The same thing will comes to inbound traffic also. But that is risky because inbound, I don't want all traffic should be open. Only which of the rules and ports, IPs, protocols I have given, only those should be allowed. That is the reason security group is stateful or stateless. Security group is stateful. NACL is stateless. So what is the meaning of stateless is, if I allow a rule or if I add a rule at inbound rule, automatically it will be added to outbound also. Okay. But if it is stateful, I need to configure my own rules at the inbound and the outbound level. At the inbound and the outbound level, we need to configure our own rules with the stateful. Okay. So these all the differences, four differences we should able to tell. Okay, and create different NACLs, security groups, and NACLs attached to the subnets, security groups attached to instances. Okay. Yeah. Any doubts? Then another VPC also will create in another region. Then we'll establish the VPC peering also. So in the next session, VPC peering, then flow logs, we'll discuss in the next session.